Good day. How are you doing today? So in this lesson, I'm going to show you how to differentiate products. So if you're given if y is equal to u times v, where your u is actually a function of x, it can be a polynomial or a quadratic or whatever, and v also is a function of x. So these two are multiplying together to give u times v. Then the derivative, the dy dx of that, will be equal to u multiplied by dv dx plus v du dx. So what you have to do in simple terms is just to find the derivative of the u function, and you just write it here, you substitute it here, and you find the derivative of the v function, and you just substitute it here, and you just put your u and your v. Then you simplify the whole sum. Okay, let's get into some examples to explain this. So in this example, we are given use the product rule to find dy dx when y is equal to e to the power of 3x times 4x plus 5x squared. So in this case, you can say your u is equal to e to the power of 3x, and your v is equal to 4x plus 5x squared. And you can differentiate your u now with respect to x, that is du dx is equal to, remember to derive the exponential function, you just derive the f of x part, then you bring it to the front. That will be 3e to the power of 3x. Then your dv dx would just be equal to, here it's a 4 plus 10x. Now, so dy dx using the product rule, that will be equal to, remember that is u dv dx plus v du dx. So in this case, that will be your u, it's just e to the power of 3x, multiplied by dv dx, that will be in a bracket 4 plus 10x, bracket, then plus v, it's 4x plus 5x squared, multiplied by du dx, and that is multiplied by 3e to the power of 3x. Then you can just rearrange this whole thing, and that becomes like 4 plus 10x in a bracket e to the power of 3x plus 3e to the power of 3x, then in a bracket 4x plus 5x squared. Yeah, you can simplify this further by just factoring out this e to the power of 3x, then you can write the final answer. Now, in the next example, you are asked to determine the derivative using the product rule. So in this case now we have again, let's say our u is equal to 3x squared plus 2x, and our v is equal to ln bracket x cubed plus 2x. Now, then you find your du dx, and that will be 6x plus a 2. And your dv dx, remember how to differentiate the logarithmic function? If you have forgotten, please revisit the previous lesson. So to differentiate that, remember you just find the first derivative of this algebraic part, and that will be 3x squared plus 2, then divided by, you just rewrite the whole function, x cubed plus 2x. And remember now, for product rule, dy dx is equal to u dv dx plus v du dx. And that's equal to your u first, which is 3x squared plus 2x in a bracket, multiplied by dv dx, that will be 3x squared plus 2 divided by x cubed plus 2x, then close bracket, plus v ln bracket x cubed plus 2x, then in a bracket times by du dx, and in this case that is your 6x plus 2. And that's how you find the derivative of this product. Then in the last example, we are asked to find the exact coordinates of the turning point on the curve y is equal to ex bracket 1 plus x, and determine the nature of this point, whether it's a maximum or a minimum point. So remember, we've got a product again. So we let u is equal to e to the power of x, and our v is equal to 1 plus x, and du dx, in this case, will just be equal to ex, and dv dx will just be equal to, that will be a 1. So remember, by product rule, dy dx is equal to u dv dx plus v du dx. And that gives us our u, it's e to the power of x, then times dv dx, that's a times 1, plus v, that will be 1 plus x, multiplied by du dx, in this case, that will be your e to the power of x. And the final answer can be written as, so you can factor out here the e to the power of x, and that will be a bracket 1 plus 1 plus x, and that will be equal to e to the power of x in a bracket 2 plus x, and that is your derivative. But remember what we want to determine, we want to determine the turning point. So remember, at the turning point, the first derivative is equal to 0. So then we say 0 is equal to e to the power of x bracket 2 plus x. So 0 is equal to e to the power of x, or 0 is equal to 2 plus x. And remember now, this is undefined because there is no any number that you can raise to the power x that you get a 0. So therefore, your x would automatically be equal to negative 2. Now, after I've gotten your turning point, you want to determine whether it's a maximum or a minimum point. And to do that, you have to find the second derivative. And you have to find the second derivative of this function here. And then you substitute the x equal to minus 2 into the second derivative. So you find the second derivative, and then you substitute the negative 2 into the second derivative. And if it's greater than 0, you actually have got a minimum point. And if it's less than 0, your second derivative is less than 0, then you have got a maximum point. So let's just do that quickly. So to do that, again, we need to do, again, the product rule. So in this case, our u will be equal to e to the power of x. Let me just erase that and make space. So remember now, the first derivative dy dx is equal to e to the power of x bracket 2 plus x. So we let our u for the second derivative now. So u will be equal to, again, e to the power of x, and v is equal to 2 plus x. Then we derive that, and we get du dx is equal to e to the power of x, and dv dx will be equal to a 1. Then remember, dy dx with product rule is equal to u dv dx. Always write down your formula. U dv dx plus v du dx. And that will be equal to your u, it's e to the power of x in a bracket, dv dx times 1 plus v, and your v here, it's 2 plus x bracket times du dx, that is e to the power of x. And you can simplify this further to be e to the power of x outside the bracket, then 1 plus a 2 plus an x. And that gives you e to the power of x bracket 3 plus x. Then you substitute that 2 into the second derivative. So this is your actually second derivative here. So the second derivative is ex bracket 3 plus x. Then you substitute your negative 2 to determine if it's greater than 0, so that it's a minimum, and less than 0, so that it's a maximum. So if you substitute negative 2 e to the power negative 2 there, that's actually a positive number. Bracket 3 minus 2, that's actually a positive number. So what it means is that we have got a minimum point. So the result here will be positive. So then we have got a minimum point. And that's how you do the product rule. See you in the next lesson.